In this video, I'd like to give proper attention to the way in which we declare and assign values to variables, and to work some examples to help us understand what can originally be a difficult process. Now, we've seen a couple examples previously of declaring variables, and I said out loud but did not write down the way in which we always declare variables. We must declare the variable name first. That must go on the left-hand side of an equal sign. And the value that is to be assigned to that variable name should be here on the right. This value can be a literal value, as it was in our circumference and area of a circle example when we had pi equal to 3.14159. That was a literal value that I put in here. Or it's also fine to declare a variable name like we did with circumference and set it equal to an expression that involves previously defined variables. It's very important that if you use variables on the right-hand side for the value in which we're going to attribute to the variable name, it's very important that they be declared earlier in the flow of control in the program. For now, what flow of control of the program means is higher up, an earlier line number. They need to have been encountered first. At this point in time, flow of control for our program starts at line number 1, reads left to right, and then moves on to line number 2 and reads left to right, just like we would read a book. We'll deal with flow of control later on in the course, and we'll make that more interesting, but for now, it would be just as if you were reading. If you want to read a statement like this out loud in a way that can help you understand the order in which the computer is handling a line like this, I think it's really nice to interpret this line as variable name is assigned the value of whatever is over here on the right. That can help you when code starts to get a little bit more complicated, like what we have down here. For example, over here on the left, we declare a variable named x that is assigned the value of 4.2. Next, we declare a variable that is to be named y, and y is assigned the value of 3.1. When we look at this next line of code, the question is, what is happening here? One of our variables is being reassigned a different value. If we just use this rule for reading out this third line, it will help us understand exactly what's going on here. What's happening here is that the variable x is being assigned the value of y. Remember that y is the name of the locker, and 3.1 is what's inside the locker. So x is being assigned the value of y. X is being assigned the number 3.1. So before this line of code, x held the value of 4.2, and this line of code is changing the value of x to whatever the value of y is. So when our flow of control reaches this line, print x, what should be printed is the value of x, and the value of x at this point should be 3.1. The first two lines of the code over here on the right is exactly the same, so we don't necessarily need to step through that. Let's think about what is happening in this line right here, because I have a y on the left and a y on the right. If you were to read this line like a mathematician, y is some number that is equal to 2 times itself, you would conclude that either y is equal to 0 or 1 is equal to 2, and since 1 is definitely not equal to 2, this would mean that y would have to be 0, but that doesn't make any sense because y was supposed to be 3.1. So again, don't read this line like a mathematician would. A computer scientist would read this line as y is assigned the value of 2 times y. Now what the computer needs to do is, before it makes the assignment to y, it needs to know this value numerically. So the first thing that happens in this line is that the computer looks up the value of y. It has not yet reassigned the value of y. So when the computer hits this line of code, it first looks up the value 3.1 and replaces this y in the code with 3.1. Next, it does the multiplication, 2 times 3.1, giving us 6.2, and once it has that number, 6.2, it assigns the value 6.2 to y. Calling the print function on y would then show us the value of y, which is 6.2. Because lines like the previous page, y is equal to 2 times y, can be a little bit confusing. There's a y on the left, a y on the right. This isn't mathematically what you mean in a computer science context. When you see this is not the same as what you mean in a mathematical sense when you see a statement like that. There's an alternative shorthand that you can use, which is to say y times equals 2. This line of code has exactly the same meaning as this line of code. What this line would mean is take whatever is currently in y, multiply it by whatever number is over here, and once that computation is done, replace what was in y with that new value. And you can do that with any of your arithmetic operations: addition, subtraction, multiplication, or division. Thinking about those things and the way we worked through everything on the previous page, I'd like you to take a look at these 4 examples. The fourth one is harder than the first 3, but I'm going to end this video displaying these examples. I want you to pause and work out what you think would be printed in each case. It's okay to have a question mark here, or on any of them really. And when we resume the next video, I'll go over the answers.